Welcome students. In this video, I'm going to discuss different type of sets. First, I begin with the finite set. If the elements of sets are finite in number, then that set is known as finite set. Some examples of finite sets are, look here, the set is written in the roster form 1, 5, 25, 125. Number of elements are 4, so that means they are finite in number, so this is a finite set. The set of months in a year is also a finite set, because we know that the number of months in an year are 12, so this is also an example of finite set. The set of all states in India is also a finite set. Second set is infinite set. If the elements of sets are infinite in number, then that set is called infinite set. Some examples are like the set of natural numbers. We know that natural numbers are infinite, so this is an example of infinite set. Next is set of whole numbers. Whole numbers, they start from 0, 1, 2, 3, 4. Like the natural, they are also infinite in number, so this is also an example of infinite set. Set of integers. Now integers include whole and the negative of natural. So we have 0, 1, 2, so on. And here -1, -2, these are negative integers, right? So the integers are infinite in number. So this is also an example of infinite set. Next is singleton set. Now set having one element or a set which contains only one element is known as singleton set. Some examples are like I have written the set A as it contains only one element, which is 0. Set B, it also contains one element, E. Now set C, set of those x where x belongs to integer and x is greater than 2 and less than 4. We know that x is greater than 2 and less than 4. So there is only one integer, which is 3. That means again this set contain only one element. So this is also an example of singleton set. Set which contains only one element. Next is empty set. You can also call it as null set or void set. Now a set which contains no element is called an empty set or null set. Now it is denoted by these two symbols, either this phi or only bracket. I am again repeating, you can denote the null set or empty set by this phi or these bracket, right? But you will not write like this. This is incorrect because this is a set which contains an element whose name is phi. So that means now it will be an example of singleton set. So null set either by this symbol phi or these bracket, empty brackets. Now examples are A is a set of natural number less than 1. We know that there is no natural number which is less than 1. So this is an example of null set or void set. So I'll write either these brackets or phi. Now another example B, set of those x where x belongs to z, z for integers, and x is greater than 2, less than 3. We know that there is no integer between 2 and 3, right? So that means again this is an example of null set. First question from exercise 1.2. Which of the following are example of null set? Set of odd natural number divisible by 2. Now, we know that there is no odd number or natural number which is divisible by 2. That means this set does not contain any element. If it does not contain any element, so this is going to be an example of null set. Next, set of even prime number. There is only one even prime number, which is 2. So that means now this set contain one element. So this is a singleton set. That means this is not a null set. Now fourth part, y. Y is a point which is common to any two parallel lines. Just look here. Now these are parallel lines. Clearly these parallel lines does not contain any point which is common. So that means this set does not contain any element. So this is also an example of null set. Second question, which of the following sets are finite and which are infinite? The set of months of year. There are 12 months in an year, so this is a finite set. 1, 2, 3, so on. This is an example. This is natural set. So this is infinite set. The set of positive integer greater than 100. Greater than 100 means you will start from 101 and the counting will goes up to infinity. So this is also an example of infinite set. Next, equal sets. Two sets A and B are said to be equal if every element of A is an element of B and every element of B is also an element of A. For example, 3, 7, 9. 7, 9, 3. We know that order of writing the elements is immaterial. These two sets contain same element. So this is an example of equal set. Now 3, 9, 27. Here x, set of those x such that x is equal to 3 raised to the power n. N belongs to natural. Now look here. N is a natural. So we'll start from 1. So 3 raised to the power 1 is 3. Next we have to put n equal to 2. 3 raised to the power 2, which is 9. Now n is 3. 3 raised to the power 3, 27, so on. So that means these two sets are equal. Question number 5. Are the following pair of sets are equal? Set A is 2, 3. Set B, x. Set of those x such that x is a solution of this quadratic equation. So first we are going to solve this quadratic equation. X square plus 5x plus 6 equal to 0. Sum of root is 5 and the product is 6. So roots will be x square plus 3x plus 2x plus 6 equal to 0. Take x common. We'll have x plus 3. Here take 2 common. This is x plus 3 equal to 0. So x plus 3 into x plus 2 equal to 0. That means the roots of this quadratic equations are minus 3 and minus 2. So set B is minus 2 comma minus 3. Clearly these two sets are not equal. A. X is a letter in the word follow. So letter will be F comma O comma L. We'll write the letter only one time. This is repeating. So we'll not write it again. Comma W. And B. Y. Set of those Y's such that, so I'm again repeating, set of those Y's such that Y is a letter in the word wolf. Wolf. Right? So first letter is W. Next, comma O, comma L, comma F. Clearly these two sets are equal.